So we're going to start factoring today. Here's the point of factoring. Shh. Very, very soon, I'm going to be asking you things like this. Hold on.
Is that a 5?
Yes. Now this isn't exactly what we're doing today, but I'm showing, actually, let me change a little bit of this. I'm going to show you what the point of this stuff is. And I'm going to be asking you, sooner rather than later, you'll be amazed how quickly we're going to get to this level of complicatedness. Sorry, that's a 10 and a 12. And I'm going to be saying things like, graph that, without a calculator. And you're going to actually, believe it or not, know how to do that. And one of the biggest things about graphing that I'm going to be looking for, and that they look for across the state when it comes to graphing polynomials, is when you graph it, where does your graph cross the axes? Well, I'm going to quickly work this one. I'm going to factor it. Now, you won't have learned this factoring stuff yet, but I'm going to show you how factoring this can actually make the graphing really simple and without a calculator, which is why we have to spend so much time on graphing. For instance, you would start by factoring out a 2x out of this polynomial, and this is all what you're going to learn here very soon, which would leave you with x squared minus 5 plus 6. That's actually the part we're doing today, is I'm going to teach you how to do that kind of factoring.
Where'd you get 6?
Well, we're not there yet. I'm going to show you all a little later. I'm right now showing you why we're learning this.
Okay.
Then I'll show you how to do
So
it.
this is a different problem? Wait, so on the front number, you take out the number and the x, and then you carry over the other two you got left over into the...
Actually, yes, and that's what I'm going to be teaching very soon. Now, then you would factor the right-hand side into x minus 3 and x minus 2. Now, at this point, it's fully factored, and I'm not even going to show you how to do all this today, just this first part. Here's the point of fully factoring. If I covered up these two and just had this, 2x, what could I plug in for x that would make that equal to 0? 2 times what equals 0? 0. That's a 0. What could I plug into just that portion to make it equal 0?
0.
No, x minus 3. What minus 3 equals 0?
3.
What about x minus 2? 2. So, if I was to graph that, now that it's fully factored, what's 0 times anything? 0. So if I plug the 2 into this equation, I would have 0 times something, which is all 0. So to graph this, I would now know immediately that the zeros, where I cross my axis, is 0, 3, and 2. If you were to graph this function, which is what I'm going to do right now on a calculator, I guarantee you that that original function at the top will cross the axis at 0, 3, and 2. Which is what you're going to need to know how to do, which will be much, much harder if you don't know how to factor. Let's see, zoom 6. Oh, sugar. What the heck did I do? Oh, oop, x squared. Squared plus 12x. Graph. Boom. Look where it crosses the axis.
Oh, it makes an N.
0, 2, and 3. Just like we saw just 2 seconds ago. And you're going to be able to do that kind of thing too. In a few weeks, I'm going to be able to show you a function like that, and you're going to be able to tell me, oh, it's going to go down and then up, it's going to cross in those 3 places, it's going to top out here and bottom out right there.
Yeah, I was going to go zigzag.
Depends on the function. That's a good question. I'm going to teach you that too. But the first thing I'm going to teach you is how to find where it crosses the axis, the roots or zeros of the function. And we have to start by factoring. By the way, we have new calculators. We have nice pretty yellow ones and white ones, and these are actually really good. If you want one, you need to, it'll be first come, first serve when you come into class every day. If you want a good one, you might want to grab one. All right. The first thing that we're going to cover today, I don't know why it's written up there twice, is how to factor just what the polynomial has in common across every piece. That's the only thing we're working on today. What does every piece of the polynomial have in common? You're going to have to go letter by letter, and you're going to have to go by the number. Now, first off, you're going to start with the numbers. 6, 2, and 6. What is a number that divides into all three of those evenly? 2. Very good. 2. So the first part of factoring this would be 2. You factored out the number. Now, how many x's? Now, here's what I mean by the x's. And I tried to put this in hunting terms for someone last class because they seem to be a hunter. I'll try to do that again, although it may not make sense to any of you. It's kind of a stretch of an analogy. But imagine,
Killed one last night.
can't they take your gun if you hunt out a season or something?
What?
Dude, don't they like take your gun if you hunt out a season?
No,
If
that
you're
depends on
underage.
if you get caught or not.
If you're underage, they take your gun. If not,
Okay.
they just give you a fine.
Let's pretend we did some kind of hunting violation. Now let's say Mick has 2 guns, I have 1 gun, and Justin has 3 guns. And we're all caught in the forest together. But the warden, we all did the same punishment, but they have to make the punishment fair for all of us. So how many guns could they take from us individually that would be fair?
One.
Why only 1?
Because
You have one.
Because I only have 1. Now even though he has 3 and he has 2 or vice versa, it's only fair if you take 1 from all of us, because if they took 2, I couldn't give them a second one, and that wouldn't be fair to those guys. Factoring letters is the same way. This one has 2 guns, 1 gun, 3 guns. What's the most they can take? 1.
I killed a deer last night talking about.
Okay, you are losing focus. All right. 1x. Now, look at the y's. How many y's could I fairly take out of all of those? 1. Very good. Now, we've gone through the numbers, the x's, and the y's, and we've taken out the most that we could. Believe it or not, we're almost done. But the whole point of factoring is like, if I factored...
Yeah.
School's over! Good, was the longest bell ever. Now, if I factored 8 into 2 and 4, couldn't I then get back to it by multiplying 2 times 4? Similarly, when I factor this, I should have 2 things next to each other that if I chose to multiply them back, I would get to my original. Now, if I said 2 was a factor of 8, how could you find out that it was multiplied by 4? Couldn't you just divide?
Yep.
And you say, hey, 2 is a factor with 4 because 8 divided by 2 equals 4. Same thing, if I factor out 2xy, I can find out what I'm supposed to have left if I multiply all 3 pieces by 2xy, which is what we did Tuesday. We factored by a monomial. What's 6 divided by 2? 3. Now this is going to go in parentheses because we're erasing. Because we're multiplying. So, 6 divided by 2 is 3. What is x squared divided by x? X. What's y squared divided by y? Y. Minus. What's 2 divided by 2?
1.
Very good. X divided by x? Nothing. X divided by x cancels. Y squared divided by y? Y. Plus 6 divided by 2? X cubed divided by x? X squared, and then the y's cancel. This is the fully factored polynomial.
This is easy.
I'm glad you think so. To check your work, you can always just multiply that back through, and you should get back to your original. You should.
So what you do is you get the factor all of them, and that's the 2 and the x and the y over there.
Yep.
And then you take that and divide it by all the top ones up there, and then you write that in parentheses.
That's right. This piece, I always thought it had a funny name. What's left after you factor something out is called a depressed polynomial. That's its actual name. And I always thought it was called that because it was sad that you tore part of it away. So you have your factored portion, you have your depressed polynomial, and it's factored. And here is, there you go, 2xy times 3xy minus y plus 3x squared, which is exactly what we just had. Yes, sir?
So you just got that 2xy at the beginning from just putting it into 6 and 2 and 6.
And then x and finding out the hunting analogy thing. Yeah. Yeah, exactly. Let's look at some more.
I thought we had to graph this.
No, that's coming much later on. What we're going to be doing for the next 2 weeks is all building up to graphing. Building up. Well, there's so many things I have to teach you. about the graphs before we can get to them. Boy, they are just bell happy today. All right, let's look at another one. How's about 9? We're going to factor 9x cubed y to the 4th minus 3x squared y squared plus 6x to the 3rd y to the 5th. We're going to factor that. First things first.
Wait, I got a question.
Yes.
It's 3.
3.
Pause. Yes.
What if you can't factor it?
That is an excellent question, and I'm going to show you one like that in just a second.
Okay.
All right, first things first. Jared, what number comes out of 9, 3, and 6? Don't you dare listen to him. What number multiplies evenly into 9, 3, and 6? Very good. 3. Now, shh, guys, what is the lowest amount of x I can take out?
2.
2.
And y is 2.
That's very good. Thank you. Very good. Now,
I bet Hibbern's gone now.
that's factored. Now we have to multiply all 3 pieces by that.
3x, y 2.
Jared, did you ask if you could say it?
Huh?
Stephen, no, you can't. You've been saying stuff all day against my will.
3x, y 2.
Be
Yeah. It's just
quiet, please. We're going to do it right
that
now.
whole thing I'm parking today.
That's exactly right. That's how I made this one the example. Mackenzie, what's 9 divided by 3?
3.
X cubed divided by x squared.
X.
Just subtract the exponents.
What is that?
1. 3.
What'd you ask, Justin?
Why can't you just put x instead of that?
You can, but just to make people see that all you really have to do is subtract the exponents, I'm putting extra first.
Oh, y squared.
Factoring.
Factor?
Y squared.
Factoring is a very broad term that's going to cover like 6 different lessons that we do. But it's all factoring. Okay, y squared. Now, I heard an excellent question. What happens if an entire piece cancels? Well, let me ask you this. Actually, before I ask you, what most people do and mess up here is they think, ooh, everything cancels, it goes away.
Put a 0.
What you have to remember is, when you multiply back through, you have to get the same thing. So remember it like this. What's 6 divided by 6?
1.
What's anything divided by itself?
1.
You have to put in a 1 if everything cancels. Otherwise, if you leave that blank, if you were to try to multiply back through to get your original, you wouldn't, because this middle term would just vanish. Yeah. And
3x, y 3. Plus
2x y cubed. Questions on that one? I'm glad you think this is easy. Yay! If there's no questions,
Homework.
well, not quite.
Dang.
We're actually really close.
Do one that you can't.
This is one that you can't. This is one that you can't. Notice, there is not a single part. There's like 5 letters and all kinds of numbers, but there's nothing that these 3 things have in common. 3, 15, and 25, no common numbers. I had a smart aleck first block say, what about 1? Well, that's true, except what good does that do you to divide by 1? None of the letters are in common. If nothing can be factored, then you just say it's prime. That's what you would put it.
But the first thing you
Okay,
figure
so
out is that no number goes into all of those.
Exactly. And then you look for the letters that are in common, and there are none. They have to be in all 3. Good question, kids. Questions?
No. Homework.
Pause.
I'm just ready for this homework. This one is 3.
Because he knows how to do it.
Can we kick them out of class?
I'm thinking about it.
Pre-calculus.
I'm thinking about it.
Who are we talking about?
I thought you liked participation.
I do, but there is also such thing as sarcastic participation.
Especially whenever you
That's
use
right.
3! That doesn't help the other 25 people in the class. Give them a second to think.
For sure, right there.
Oh.
Okay.
Those 5 problems are your assignment for the day. When we get back from lunch, I'm going to have a bonus opportunity. It's a thinking question.